All right. Good stuff. Here we go. Good stuff. So, thank you everybody for coming. I appreciate that you could be anywhere, and we have a lot of great choices. So, thank you very much for coming to my my humble session today. So, we're going to go through a lot of stuff today. That's my custom. I like to go through as much as possible, and trust that you'll be able to figure out the details if you want by consulting that GitHub repository on the top there. That's the sort of code, and it's also a 3-day lab where you'll find lots of sort of details and step-by-step exercises that you can follow to understand what we're going to look at here today. And there's also spring.io/guides where you'll find all manner of different guides, topical 15-minute long introductions to all things Spring and Spring Boot and Spring Cloud and so on. I'm online, so if you have questions, comments, feedback, whatever, please don't hesitate to reach out to me. I'm on the internet. I'm happy to answer questions. So how many of you are on Twitter? Twitter. Good stuff. Hot sauce. Well done. So if you're there, find me there. I'm happy to talk, happy to answer questions. I'm here for you. What about email? Email. Does anybody have email? Email. Okay, well, I'm there as well if you've got comments, questions, feedback, whatever. Again, I'm happy to engage. I wanted to just lay this out here. I took a poll, and if I'm honest, I didn't really like the results, but whatever. So I want you to know that what I'm trying to do in this talk, because I've already given, I gave a talk last year that covers some of what we're going to talk about in this talk, and I was thinking, there's some new stuff, and I want to show you some of the new stuff, of course, but I can't afford to skip to the new stuff without making sure I cover the old stuff, so I was looking for ways to go faster, to cram more in, because if you've ever seen my talks, you know that I go in a lackadaisical sort of slow manner, and I don't cram a lot of stuff in. It's very sort of easygoing, right? So this time I was looking for ways to go a little bit more quick, and I was going to use Kotlin, but that didn't happen. So, what the heck? Anyway, a little bit about me. My name is Josh Long. I'm the Spring Developer Advocate on the Spring team. I'm an open source engineer and contributor. I'm the number one top ranked for 7 years. Number one contributor of bugs, but still number one contributor of bugs to projects like Spring Boot, Spring Cloud, Spring Integration, Spring Batch, Vaadin, Time Leaf Activity, etc., etc., etc. I've also done training videos, for example. So the latest and greatest of which is called "Building Microservices with Spring Boot Live Lessons." It's by my friend, the one, the only, the amazing, the inimitable Phil Webb, the co-founder of Spring Boot, and myself. And then there's a Cloud Native Java, and that book is all about how to build applications that survive and thrive in the cloud, very much like what we're going to talk about today. And for those of you who are wondering, that bird is a blue-eared kingfisher. It's a bird that is indigenous to the Java Islands in Indonesia. It's a bird that is native to Indonesia, to the Java Islands. And now birds, you see, they project themselves through the air, through the clouds, with the greatest of ease. They fly, you see. So this is a bird that is native to Java, that lives in the clouds. It's a cloud-native Java bird. It's a bird that's native. Never mind. It's fine. It'll come. Just give it time. Give it time. Okay? And I work at Pivotal, and at Pivotal, we've got a lot of great open source stuff, a lot of great open source software, and we care very much about the open source software. But if I'm honest, the main reason we're here, the thing that we care about the most, is helping customers and community members and organizations deliver software quickly and safely to production. A lot of organizations struggle with this, and they wonder how to capture that same sort of speed that existing organizations have, right? The web stars, the unicorns on the internet, the Netflixes, the Ubers, the Airbnbs, etc. These businesses and many others besides are software companies. They may act like other businesses, but they are software companies through and through, right? And they deliver software in a software timescale. They go fast, and they realize that the first that is able to get to market is going to win. So the question is, how can we, with our large existing monolithic applications, capture that same agility? And one way to do that is to decompose your large application into smaller batches upon which a smaller group of people can work. A small batch of work that can be focused, deployed, tested, and developed, and then deployed into production by a small group of people. Oh yeah, right on. a small batch of work that makes it easier for people to reason about what's going to happen if you make a change to the code base, right? A small batch of work that can be deployed independent of other parts of the team in the organization. This makes it much easier for people to move within their own sort of swim lane, to be able to go faster without having to have constant meetings with other parts of the organization. So the question is, how do we do that? And we, if you've been paying attention, you know that the answer is to use what is called a microservice, right? Microservices are small, singly focused, internally consistent, reusable, bounded contexts. They're parts of the application that have been decomposed from the larger application and that have been that are optimized for small teams. That allows you as an organization to go faster. But when you move to microservices, you invite complexity, and that complexity is something that you must address up front if you're going to have any success at all in this architecture. There's a lot more places where you can hurt yourself, basically, when you move to microservices. So in this talk, we're going to look at Spring Cloud as a way of sort of mitigating a lot of these concerns. So we're going to go ahead and build a new service today, and we're going to go up to start.spring.io here. This is my, oh, not this again. We're on the same IP, so every time I go to this thing, it makes me verify. Okay. Select all the images with a house. I don't want to. This is happening. We're doing this. I'm going to win. Did I win? No. Oh, I'm human. Whew. Thank goodness. Well, so what I'm going to do is I'm going to create a new service. I'm going to call it the Reservation Service. And this service is going to use the dev tools, which is a nice feature in Spring Boot to be able to reload services or reload applications during development. I'm going to use the web support in Spring Boot. I'll use the REST repository support. I'll use Actuator for operational concerns. I'll use the config client for centralized configuration. I'll use Eureka for service registration and discovery. I'll use RabbitMQ stream processing for stream processing. I'll use Zipkin for distributed tracing. I'm going to use I'm going to use H2 first of all. I'm going to use an in-memory embedded SQL database, and because it's in memory and embedded, it's going to lose all of its data on every restart. So it's just going to lose its data after every restart. Very similar in this way to MongoDB. It just loses its data all the time for no reason at all, just all the time, just gone. Okay, so I'm going to use H2. It's very web scale, except that it only works on one node in one VM. And then we're going to use REST repositories, right? And the REST repository support will make it easy to build a repository that is exposed over the web. And our repository in this case will use JPA. And then I think that is enough for now. Web, Actuator, Config, Eureka, Zipkin, REST DevTools could do. Let's leave it there. Okay. So what I'm going to do is I'm going to build a simple service using this new project. Now, how many of you have had the pleasure of using Spring Boot? Okay, very good. So I won't linger too long. I won't tarry too long in what Spring Boot is, but suffice it to say, it makes it easy to stand up applications and to get results quickly. It is optimized for sort of handling the non-functional requirements implied by moving to production. So for now, I'm going to go ahead and comment out this RabbitMQ thing. We'll need that later, but everything else I'll leave it on the class path. And what I'm going to do is I'm going to build a simple service here that manages entities of type reservation. And again, a reservation is just an object that we're going to use. I don't care about the domain all that much. I just need something so we have something with which to play for the balance of our time together. Now, this entity will have a primary key, a surrogate auto-incrementing ID right there, right? At generated value and at ID. And we'll create a constructor there, right? We got another constructor for JPA and JPA only, right? There's that. Create a toString method. We'll create some getters. There's this, right? We'll signal that this is a JPA entity by using that annotation. And then that, I think, will do. We've got some getters. We've got a primary key. We've got a constructor. We've got a constructor for JPA. We need a repository. Now, this is a Spring Data repository. And if you saw Oliver Gerke's earlier talk today, then you know that a repository is just an object that makes short work of dealing with the underlying persistence tier. The reading, writing, and etc. with the underlying persistence tier. And I'm going to want to be able to find reservations. I want to be able to find reservations by the type of entity, by their reservation name. So I can create custom finder methods like this, for example, string rn. And I want to expose this repository as a REST API, right? My repository handles things like read, write, update, and delete, and all that stuff. I don't have to implement the interface. Spring Data will do that for me. It'll give me an object that I can inject that does all this stuff and much more besides. And so it's also in an enviable position to handle my REST API, right? Because it already knows how to do that, right? So I'm going to go ahead and map it as such. I'll say by name. And we'll say at param rn. And now I want to save some data of this type into the database, right? So I'm going to create a command line runner, and a command line runner is an object in Spring Boot that when it gets called, when it's perceived, it will have its run method invoked on application startup. So it makes it a sort of an enviable place to put any kind of application initialization and sort of anything that lives outside of the traditional request response flow of the application. So I'm going to create some records here, right? So stream.of and Andy. I'm Josh. Nice to meet you. Michelle. Okay. We've got Stefan. That's a French one with an accent in which I don't have my keyboard. We've got Oliver, Marius, whose talk you should see tomorrow. That's 6. We need a few more. Donald? No. Just no. Oh. It's been such a bad day. Do you have to? Yeah, sadness and despair set in. Bobbert. Okay, so now for each one of those names, we're going to write a record to the database like so, and then we're going to visit every record in the database by just printing it out with this find all method, right? So find all for each system out print line. Very good. And there's my simple example, right? I've got some data in the database. If we start it up, we should have a REST API. We should have some sample data there, and we should be good to go. So let's go ahead and start it up and see what happens. Now, what we want to do when we move to a distributed systems world is we want to be able to configure the behavior of the application. And if you know about Spring Boot, then you know that one way you can configure the application is to specify configuration in this property file called application.properties, which is in your source main resources directory. So, for example, my application is now running on port 8080/reservations, right? So there's my REST API. It's hypermedia. It's built using Spring HotOS, hypermedia, and this is a short acronym. It means hypermedia as the engine of application state. It's the idea that every REST response has enough information in the response for the client to be able to further manipulate that resource without any sort of upfront or a priori knowledge. Basically, it promotes self-describing services, and these links give you that information. So keep in mind later on that we're actually using what is called a resource envelope object, right? A resource object that manages entities of type T, in this case reservation, and the resource has content, which is your payload, and it has links, which are the links about the payload. So later on, we're going to turn this JSON back into a resource envelope object. Okay, so there we go. We've got our REST API, and we can do put, post, get, delete, all that kind of stuff. Now, I want to configure things, and I can do that in this property file. I can specify all different manner of things. I can say server port equals 8010, for example. But if I wanted to change the configuration, I would have to recompile the jar, and that's not really a very tenable solution. I don't want to keep my configuration in the jar itself. One option would be to externalize that configuration, to keep it, for example, outside of the jar here, and oops, may have been -d skip tests because YOLO, clean install. Okay, and then I could go here and I could say I want to run this jar, this so-called fat jar, which has everything I need to run it. I can run this jar by running java-jar, reservation service.jar, and then just overriding certain properties. I can say server.port, for example, equals 8010, right? So there's that. That's the updated version of that code, and it's going to work just as before. Everything's going to be fine, but it's now on port 8010 instead of the default, which is 8080, right? You can see that here. Whoa. So there's 8080, right? I want to override that default, and I can do that by using -g arguments. That's one way to get the result. There it is on port 8010. And I can use environment variables too. I could say export server _ port equals 8030, for example, and that would also work. But in my case, this still falls short of 4 different use cases. What if I want to centralize my configuration? What if I don't want to duplicate my configuration from one node to another, tediously copying and pasting things around? What about if I have secure information in the property file, right? How do I secure that and not keep unencrypted information at rest in a property file on my file system, for example? How do I support auditing and journaling? How do I see who changed what and when, and if necessary, to roll that configuration back, right? And then finally, how do I change the configuration while the service is running? for these 4 use cases, I need something a bit more powerful than just having properties inside my jar, and more powerful than keeping my configuration in a shell script that then is used to parameterize the Java command, for example, or set the environment variables. I could have a directory full of configuration, a directory full of property files. That would certainly give me some of what I want. I could version control that directory, right? And that would solve my centrality and my auditing requirement. But how do I sort of interpose access control or security in that model, right? It's not an easy way to do that. So I need something a little bit more sophisticated. I can use the Spring Cloud config server. The config server is just that. It's a REST API. It's a microservice that manages access to your directory full of configuration. Your directory full of configuration that's version controlled using, for example, Subversion or Git. So I have, in this talk for you, a very brand new tool that we've just released called the Spring Cloud CLI. Now the Spring Cloud CLI has amazing ASCII artwork. I think you'll agree. And the ASCII artwork is not all. It's very simple too. So what this does is you say Spring Cloud, and then you list the services that you want to run, right? Infrastructure, common things like the config server, like you could say H2 or Kafka, for example. All these are things that you could run. All of that is already running in my machine, so I don't actually have to go set it up, though I could, right? You could go to start.spring.io and build yourself a config server. So that's already running, and I've got it configured here to point to the desktop config directory, wherein I've got a bunch of property files. So localhost 8888/reservation-service/default. That's the config server. And in that config server, I can see that I've got 2 property sources, one called reservation-service.properties, and another one called application.properties. So what I want to do is I want to change my new REST API, the reservation service that we just built, and have it get its configuration from this microservice, from this config server. When it does, it's going to have access to this property called server.port. It'll start up in port 8000, and it'll have access to this message called hello world. So let's see if we can do that. We'll say, let's connect it, right? We've already got here Spring Cloud starter config, and that's the client, the driver, if you will, to talk to the config server. All we need to do now is to point it to the config server. So we say reservation-service, and that's it. That's the name of the config server of the service by which it's going to identify itself when it talks to the config server. Normally, if it was running on a non-default port, you'd also have to tell it where to find the config server itself, like this. But as it is running on the right port, I'll just leave it off. Okay. So there's that. If that works, I should be able to inject that message, that hello world message, class message REST controller, private final string value, and we'll create a constructor, and I'll inject the value as a parameter into the constructor, like so, curly bracket message, and at get mapping message string read. So all I'm doing is I'm parroting the value that I've injected here into the constructor, and I can imagine wanting to change that later on. So I've annotated this bean with @refresh_scope. Now that done, let's see. I'm going to hit Command F9, which is my compile thing, and I've got the dev tools on the class path. So it's going to automatically just restart the Spring application context, not the whole JVM, which means it's fairly fast, right? So localhost 8000 reservations. Now it's on port 8000, right? That's our new endpoint, not 8080. And message. There's our message, hello world. That's a good message, but it's not really great. You know, we can do better, so we will. I'm going to go to the desktop here, desktop config. I'll open up the reservation service.properties. I'm going to say, hello devoxx BE, extra exclamation marks, so as to reinforce my credentials, my authority on Reddit. Okay. Whoop, good. Git commit -a -m YOLO. Now, when I change that there, it's immediately visible in the config server, but my microservice, the reservation service, has no idea what we've just done. It doesn't see the updated value. So we can trigger a change by calling another actuator endpoint. Now, if you know about Spring Boot, you know that actuators are things that surface observable information or operational information, things like the metrics, for example, or the health indicator, right? These are things that are designed to support visibility into the application. There's another endpoint that is contributed by the Spring Cloud config client called refresh, which, when you send it an empty post will refresh all beans or recreate all beans in the application context annotated with @refresh_scope. It'll recreate those beans anew in situ. So let's go ahead and line things up here. I'm going to go ahead and go to localhost 8000/message. And I'm going to go ahead and hit go. And as soon as I hit go, I'm going to go hit Command-Tab to go to my browser, and then Command-R as fast as my little arthritic fingers are going to let me. Okay, so here we go. 1, 2, 3. Good. So there we go. We've updated the configuration in the REST controller immediately, right? We supported feature flags, live reloading. I've decoupled the deployment of software features in my application from the release of that software. I didn't have to restart, for example, to see that change. So by using the config server and using a version control directory, I've got auditing and journaling. I've got the config server. It's an ideal place to handle security. I can use it to require that clients have a certain authentication, for example, and I can also symmetrically encrypt and decrypt values in the property files itself. Another thing that I want to do in a distributed system is make it easy for one service to find another. You see, in a distributed system, services are going to come and go as they need to based on demand and capacity. And so we need to build our system in such a way that if one service that it's calling should fail, everything still works, right? I don't want to be coupled to IPs, for example. At first blush, this might seem like a use case for DNS, but DNS has several limitations in a cloud environment, particularly in a dynamic cloud environment where services come and go. First of all, DNS is best done with caching, but that is not a great idea in a very dynamic environment where the result might be that you have a stale reference, a stale IP, an IP that no longer matches because it's no longer there, right? That service may have been decommissioned. Another problem with DNS is that it's often used in conjunction with load balancers, and load balancers are owned by somebody else, right? So it's another piece of infrastructure that you have to ask another team to control. And really, the routing in your application is something that you should care about. It's part of your business domain. It's part of your application. Imagine you're Netflix, and you're trying to route a request from the outside world to a particular node, a particular service, and that request has an OAuth token. Where's the checkbox on your F5 load balancer that says route this OAuth token to that particular node? There is no such thing, right? It's not a common sense default, but it's something that you should be able to control. So what we want to do is be able to control the routing decisions in our application from the client before the request is ever made, not in some sort of central DNS server or load balancer. So we can use a service registry, and a service registry is like a phone book for the cloud. There are many of them out there. There's Apache Zookeeper, there's HashiCorp Console, there's etcd, there's Netflix Eureka. Indeed, even a cloud platform like Cloud Foundry can be used as a service registry. So these are all great choices. I happen to be a big fan of Netflix Eureka for a few reasons. First of all, it's super simple to set up in that I've already got it running, right? Remember this? It's also very, very good, right? It's been used at scale by one of the largest websites on the planet. It's bulletproof. So Spring Cloud has a discovery client abstraction. It's a client interface to talk to these different service registries, and it's a uniform interface. So you can swap out one implementation for another and use different registries if you like. So I'm going to go back to my build here, my reservation service, and I'm going to teach it to participate in service registration and discovery. That annotation is the same no matter which implementation you use. In my case, I've got Spring Cloud Starter Eureka on the class path. So now I'm going to go ahead and hit Command F9. And if we go to the right port here, 8761, we'll see that I've got these three things already registered, but my application is coming back to life here. Come on, computer. Oh, come on. We'll see that it's coming back to life, and it's going to register itself there in the registry. Now, once it's available, it'll be available, and it'll be advertising itself and making itself available for other clients. Before we move on, I want to draw attention to one very important aspect of this of the service registry. Very well done, mouse over. This took a long time. We have people for that. This took a year, not just a long time, a year. So good. Anyway, there's our service, reservation service. There's one instance of it right there. It's on this IP, this service ID, and this port. It's available. Now, we could register 10 or 100 or 1,000, right? So let's go build a client to talk to that. we're going to build a reservation client, and this is not any kind of client. This is going to be an edge service. So we're going to use the dev tools. We're going to use web support, REST repository support, Actuator. We're going to use the config client, Eureka, Zipkin, Hystrix, the circuit breaker, Zool, microproxy. Anything else? Feign, because yeah. OAuth, because yeah. All right, good. So we're going to hit generate. And what I want to do here is I want to build an application that manages external concerns, external client kind of concerns, right? So in a typical microservice system, you're going to have lots of different kinds of clients that are going to talk to your system, your services. And so we need to be able to accommodate those clients at a single place rather than retrofitting every single microservice to be aware of these other components. So we're going to say that we want to take advantage of Discovery Client, for example. And one kind of concern is, how do I proxy requests from the outside to my services? I could, if I have an HTML5 browser client, it's going to run in a secure sandbox. It can't make calls to my downstream services, right? So what I need to do is unless I add access control headers to every single one of my microservices, the best solution is to proxy those requests through a single node and then send them to the downstream services instead. I don't want to have to add access control headers to every single deployed microservice. I'd very, very quickly end up in a situation where I'm spending all my time changing existing microservices just to accommodate the introduction of an HTML5 client into the system. And forget about what we have to do for Android and iPhone and your PlayStation and your Roku and your Tesla and your smart TV and all these other devices that have IP addresses, right? In Singapore, the roads have IP addresses. On this planet, there are human beings walking around with organs that have IP addresses. So virtually anything can be a client. And rather than changing every single microservice to accommodate these new clients, you handle that in the edge. So let's talk about proxying, right? We can do this very naturally using the Zool microproxy, right? If we run this, oops, we don't want to run it yet. Let me comment out a few things here. Hold. Okay. We don't want the OAuth stuff right now because it'll secure everything unless we tell it to. And we don't want RabbitMQ just yet. I do need that though. So Spring Cloud Starter Rabbit. Okay. Good. So I've got now an application that's going to automatically set up a proxy for us. And now the Zool microproxy, I'm sure you know, is named for Zool in the first Ghostbusters movie. This is Zool. Now, Zool is the guardian to the underworld, or the proxy. See what they did there? It's based on Netflix, and Netflix does movies, and that's a movie. And in the never mind, it's fine. It'll come. So anyway, Zool is a microproxy, and it takes, in conjunction with Spring Cloud and the Discovery Client, it's going to automatically set up routes for us based on the IDs of these services that are in the registry. So I can go to the reservation client here on port 9999, and I can go here and I can say reservation-service/reservations, right? And there's my proxied results, right? So this is the actual proxy service. Here's the actual service here on port 8000. Whoops, localhost 8000 reservations. There we go. So actual service, edge service, actual, edge, actual, edge, actual, edge, actual, edge. You see, there's a few things here that you may be wondering about. First of all, the URLs. These URLs are different depending on who you ask, right? And that's because when the proxy makes a request to the downstream service, it does it by looking at the service ID in the URL in the context, and it makes a request to the downstream service, and it passes a bunch of headers that tell the downstream service what the origin URL is, the host, the port, the protocol, etc. All that stuff is there. The other thing you may be wondering is, how does it make the request? How does it know to which node it should route that request? And it does that using client-side load balancing, right? Right now, we know there's one instance of that service in the registry. There may be 10 or 100 or 1,000. So it has to pick. It has to say, I want a particular node, like Pokemon. I choose you, right? So it does this in the client. It has an object, a strategy that it uses to make that decision. It's a strategy that you can override. It's just an object. You can unit test the load balancing strategy. You can version control your load balancing strategy, right? So you have now the ability to do data center aware load balancing, or load balancing that is sensitive to an OAuth token, or you can do data sharding or data locality based load balancing, or whatever you want. You can say, based on the NASDAQ or something, right? You could load balance or to a particular node. So all that is pluggable, but we're using the default implementation, which is round robin. So that's certainly a good enough first start. But sometimes you want to synthesize a particular view of the data for a particular client, right? Rather than just proxying the data back and forth, you want to create an adapter API. Maybe you have a client that needs a specific view of some of the data, and so we can do that as well. So we're going to say class reservation adapter API REST controller, because I am nothing if not succinct, right? So, and what I'm going to do is I'm going to create an endpoint here. It's just a REST controller that lives on the edge service. And I'm going to create an endpoint that returns a collection of strings, right? So what we're going to do is we're going to return the strings from this JSON data. We're going to call the downstream reservation service using a REST call. And we're going to take the JSON, we're going to turn it back into a resource envelope object, and then unpack it and just keep the name, Andy and Josh and Michelle and so on. We're going to keep those names, but we're going to discard the surrounding sort of JSON strata, keeping only the names. Now, I could use the REST template here. The REST template in Spring is just a HTTP client. It makes it dead simple to call other services. But a common thing that people struggle with when they move to a distributed systems world is, you know, they have to write all this low-level sort of HTTP and messaging code to communicate. Well, there is a way that you can get past that with REST. There's a nice library called feign. How many of you know feign? So in English, feign means to pretend, to act as, right? To pretend that you're doing something. So if you see an animal, for example, laying in the forest with its tongue hanging out, and it's, you know, it's shaking a little bit, but you can see it's closing its eyes and it's pretending it's dead. It's feigning to be dead because it doesn't want you to bother it, right? It's feigning death so that you'll leave it alone. In the same way that WebSphere feigns utility. It's not actually utility, but it pretends to be, right? So what we want to do is build a REST client that can call our downstream service as quickly and concisely as possible, still using REST, still benefiting from the inherent benefits of HTTP, but without writing too much low-level code. So I can do that here by saying @enable feign client, and we're going to build a client interface here, Reservation Reader. And in the reader, I'm going to describe the kind of data I want back. I want data of type reservation, right? I want to call the downstream REST service and turn it into a reservation, and we'll talk about that in a second here. And then I want to call the read. I'm going to call it a read method. It could be called whatever, but you can call this get reservations or whatever you want, right? It doesn't matter. I'm going to tell feign that this is a feign client by annotating it accordingly. And I'm going to tell it that I want it to make an HTTP call to a service and then to do load balancing with ribbon, or to an HTTP URL. In this case, I'm going to use a service. Similarly, I need to tell it how to make the request. So I'm going to annotate this. I'm going to say request mapping equals HTTP get value equals reservation. So it's going to call the downstream service. It's going to call an instance of this service from the service registry. It's going to pick one. It's going to make an HTTP get call to the reservations endpoint. It's going to take the JSON and convert it into a collection of hypermedia resources whose payload is of type reservation. Now, I could have copied this Java type from the service implementation, but I don't want to couple my client and my service to each other. So I've created a client-side DTO, a client-side representation. In a more complex system, you might look at things like Google protocol buffers or some sort of schema so that it's easy for clients to interoperate and agree upon a common subset of the data that they need. In this case, though, I've got just one field, so we're probably okay, right? There's that. And there we go. So now I can rewrite this code. I'm going to say that whenever somebody makes an HTTP get call to /names /reservations, then they're going to call this endpoint, and we're going to use our reservation reader here, and we're going to inject that reader in the constructor, or not, come on, and @autowired it, okay? Now, I'll say this.r get the reservations get the content, which is the links, right? Stream over it. Map from reservation to reservation name. We're going to call the reservation name on each method. Okay, so there we go. There's our updated adapter API. Now, if I call this API and the downstream service isn't there, if this downstream service isn't there, what's going to happen? It's going to try and load balance, right? It's going to call different services and it's going to try and load balance. And if there are 0 instances in that service in the registry, what's going to happen? It's going to blow chunks, right? It's going to throw a big fat exception, and our poor iPhone users are going to get a big fat Java stack trace in their experience. That's no way to run a railroad, my friends. We can do better. We all know what happens if you divide by 0, right? What is 0 divided by 0? Wait for it. Come on, you can do this. It says LTE. Wait for it. Should I try with the actual Siri on this thing? What is 0 divided by 0?
Sorry, I'm having trouble.
No kidding.
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
So we want to avoid making Cookie Monster sad. Okay? Don't load balance across 0 instances. So what we need to do is to account for that very distinct possibility of failure by degrading gracefully. That's a key tenet of a cloud-native system. So we're going to build in a circuit breaker here. I'm going to create a fallback method that will just return an empty array list, right? Like this. Fallback, return new array list. Okay? And we'll say at Hystrix command, fallback method equals fallback. Okay, now I'm going to activate that circuit breaker. Here, I'll say at enable circuit breakers, and then we're going to run this. Now, this is very common in high-performance websites. They'll say, oh, well, you called this search engine, but the search engine isn't available. Here are some machine-learned recommendations from across the web, for example, right? Okay, so that's the read use case, and we'll see that in action now. But what about the write use case? What if I sent a post to this service, and I wanted to write the data from the edge service to the downstream reservation service? What I'm trying to do is to make sure that if I write the data, that it eventually gets delivered. I need to guarantee that it gets delivered eventually. And I think in that phrasing, we should find a clue, right? We're going to use eventual consistency to guarantee that delivery actually happens. We can't rely on REST. I can't make a post to a service that doesn't exist, right? So what I want to do is use a basic messaging, right? I want to store and forward the write, and for this, I can use Spring Cloud Stream. And the way Spring Cloud Stream works is that it declaratively, and as a matter of convention, lets you write to downstream services that you've configured in the configuration. So you can wire together different services using messaging systems. You can use Apache Kafka or RabbitMQ or Google PubSub, for example. And by the way, for more on that, you should see a talk by my friend Marius tomorrow morning. And basically, what the way you use Spring Cloud Stream is that you have a binder. In this case, I'm going to bring in the RabbitMQ binder here. And once that's on the class path, you then describe, using a convention, right, using interface conventions, the channels that you want to have automatically hydrated for you. And these channels are just named conduits. They're objects through which messages pass. And you can use this message channel object as a Spring frameworkism. It's the same API that you use for WebSockets. It's the same API you use in Spring integration for enterprise application integration. And in this case, this channel is like a Java util queue. When data gets put into it, it's going to appear on the other end of that channel, and then something is going to take that message and deliver it to RabbitMQ, where, of course, on the other side, something can then consume it. So we'll worry about how that wiring is specified later, but for now, we just need to tell Spring to automatically bind, or to set up that binding for us. Now, I've only got one channel here because I've only got one downstream service, and I've lazily called it output, but you might have multiple. You might have products or orders or fulfillment or whatever. So there's this, and now what I can do is I can inject that channel here. I can inject the channel, and then just, suppose I had a message channel here, like that. I could say send, I can send a message, but I don't want to do that. Again, I want to be able to benefit from declarative sort of interface-based kind of programming, so I will create a messaging gateway. So we can't use Feign here. Feign doesn't make a lot of sense for RabbitMQ and Apache Kafka and Google PubSub, but it does make a lot of sense. But rather, Spring Integration's component scan and the messaging gateway support does give us the same effect as Feign, right? So here's how that looks. We say interface reservation writer void write string rn. Hello, rn, and we say at gateway request channel equals output. This is the channel that we created in our configuration there. I'm going to say messaging gateway. Okay, So there's our interface gateway, our channel, or rather a messaging gateway that's going to write, whenever somebody calls this method, it'll send the data on the previously constructed channel. And now we can write our code a little bit simpler. We can say reservation writer W, and we'll integrate that here. We say reservation writer W, this dot W equals W, okay? Et voila. Now, we say this dot W dot write equals R dot get reservation name, and we can restart. Now on the other side, we need to do the same thing in reverse, after all. We need to take the data and then write it to the database, right? So we're going to say Spring Cloud starter stream RabbitMQ. We're going to bring that in there as well. And I've got RabbitMQ. It's a message queue. It's running on my local machine. And then I'm going to do the same thing in reverse. I'll say @enable binding. And I need to create another interface to describe the incoming messages. So I'll say service channels. And I'll say input subscribable channel input. Okay. And service.channels.class. Okay. And on this side, I can just create another component. I can just say, here's a component that will listen and process incoming reservations. So I'll say I've got a component called reservation processor, and I'll say on new reservation, please do something with the request. Okay, thanks. Okay, and the payload in this case is of type string, so I can just let Spring Cloud Stream automatically look at the incoming message, and it'll marshal it back and forth based on the content type. And the channel I'm listening to is called input. And when the message comes in, I'm going to write it to the database using my JPay repository that I have on the service, on the very first service that we created. So this dot reservation repository dot save equals new reservation rn. And voila. Okay. So there's our service, and we've got the client up and running. And now we should be able to send data. So let's try it. We're going to say -h content hyphen type colon application hyphen JSON HTTP localhost 9999/reservations. And the data we're going to send is a few of my favorite doctors. Okay, so we'll send a JSON structure with a reservation name for Dr. Subramaniam. Okay. Move what? Better? There you go. I sent that one. And now, localhost reservation names. There's Dr. Subramaniam, right? So this is the edge service. I'm reading the data, but the data was written to the downstream service in the database. If I send Dr. Sire, etc., right? So I'm now using messaging to connect these systems. I've got in the configuration for the bindings, I've got here on the client, on the consumer side, I've said that if there is no downstream service available to process the message, as soon as one starts up, it's going to retroactively consume all the messages that are there. This is also a very useful feature. This is a very useful feature. What this does is it says only one message consumer will get any one given message. So by default, it's publish, subscribe, or broadcast. But in this case, we get to, one-to-one. Okay, so that's a good way to build a service that is resilient in the case of failure for both read and write. All this time, I've looked at how to build a service that is robust in the face of service outages and topology changes. It's very important to be able to observe what is happening in a distributed system. So there's a few ways to do this. For example, these systems are all instrumented with something called Zipkin, right? Spring Cloud Starter Zipkin. Zipkin is a distributed tracing server from Twitter, and we are lucky enough to have on the Spring Cloud team contributors from both Twitter and from Netflix who contribute to Spring Cloud, as well as others, right? And so Zipkin works very nicely with Spring Cloud. You just have to have it on the class path, and it's automatically, I've got it running on the side here. Remember, we have our Spring Cloud shell here. It's running the Zipkin server, and it's running on the side, and it's automatically collecting all of the traces that I've got going through my system. So I can click on this, I click on Find Trace, and then I see down here that I've got different traces, and these are all, about a minute ago, for example. Here's the total request took 32.6 milliseconds. The timings are as follows. The message originated at the reservation client, going to the reservation names endpoint. the names method, the reservations endpoint. Then it left the client going to the service, and I can see it was processed here at this timing, sort of in the flow, right? So I now have the ability to visualize the interaction between services in the system, right? This is very good for understanding sort of the interplay between services in a distributed system. Another place where that can be very useful is that circuit breaker, right? I showed you that circuit breaker. What that circuit breaker does is if the downstream service isn't there, it will see it return an empty array list. Monitoring that service can be very useful because I can use that circuit breaker to call other services that may not be available. If they're not available, I still want to be able to do something usefully, but I cannot change their systems. I cannot add my monitoring agents to their systems. So I can use the circuit breaker as sort of a proxy for monitoring their systems, and I can monitor their systems using a circuit breaker dashboard, right? Which relies upon this stream. Now this stream is a service and event heartbeat stream that's being broadcast on the edge service. It's infinite, right? So it goes on and on and on and on forever and ever and ever. It has no end. Like the skies and the oceans and the bugs in your code, just infinite, just forever and ever. So whatever you do, don't, and I cannot underscore this enough, do not curl that endpoint. So we're going to go to this Hystrix dashboard here, and we're going to paste in that URL. We'll hit monitor, and I'll go to here. I'll say make some requests on the left, and you can see the moving average trending ever upwards on the right. We can see that it says 24, 35, etc. If I were to go kill the downstream service, the circuit breaker would open, and it would go to the fallback, and we'd see that eventually it would just stick to the fallback. Basically, it would divert the train tracks, so to speak. It would prevent us from deluging the service that's trying to come back online. And we'd see that reflected here. It would say circuit is open. So these are very useful. Now, we've talked about building a service that is robust in the face of service outages and topology changes. We've looked at how to build a service that benefits from the elasticity of a cloud environment. We've looked at how to observe it. In the last 15 minutes here, we're going to go for gold. I want to talk about that messaging-based microservice. That messaging-based microservice benefits by the sort of commodity transport between services. We're using RabbitMQ to send data back and forth. We don't have to worry about how that's done. It's done by Spring Cloud Stream. And if you understand the value of that, if you understand the benefits of that, then you can see that this is very similar to sort of the pipes and filters model in a typical Unix command line, right? Pipe, standard in, standard out. I don't care what the payload is, right? The payload is as long as the payload is meaningful for the command line utility in question, then I don't care, right? Because they can still talk as long as they can speak standard in, standard out, or in this case, RabbitMQ in, RabbitMQ out, or Apache Kafka in, and Apache Kafka out. So if we understand that, then we understand that there's a possibility to build complex solutions out of microservices that are composed using messaging. And we have, to support that kind of composition, a technology called Spring Cloud Dataflow. So what I'm going to do is I'm going to build a Dataflow server. Okay, I'll say Dataflow service. Dataflow server, config, Eureka, hit generate. And now Dataflow is a service, it's a REST API, and it manages its state in a database. In this case, it's going to use the default, which is the H2, right? So I'm going to say spring.application.name equals Dataflow-service, and I will point this to a different version of the Dataflow server, the new one that's not quite released. That's why we're not using the one inside of the Spring Cloud CLI. Import this. I'm going to say @enable Dataflow server, and we're going to run this. Now, that's going to start on port 9393, and it's got a REST API, and you can interact with the REST API a few different ways. There is a Spring Cloud shell that you can use, a CLI, but I prefer to use the API, the service itself. So 9393 / dashboard. Whoops, dashboard. There we are. And what I have here are the ability to import modules that are built using Spring Cloud Stream. So I'm going to bring in some of the Lego bricks, some of the existing modules that are provided for us. I'm going to use the RabbitMQ based ones. I'm going to say bring that in here. And now that I've done that, I can go back to streams here, or rather to apps. I can see all these different components that will talk to each other, that do interesting things for me, and I can build solutions based on them. So let's say I wanted to monitor a directory, and then for for a file that appears in that directory, I want to take each line and then send a line to that RabbitMQ destination, which then gets delivered to the reservation service, which then writes it into the database. I can now create a stream by composing complex bits or singly focused bits. I can build a stream that uses a file source, right, which is a thing that produces messages. I can then transform the data from that file source using a transform component, and I'm going to send the data to a destination, the Spring Cloud Stream reservations destination. So let's connect these things together. We're going to say there's that and there's this, and we could do this the manual way up here, or you could click on the gear icon here, and we could say, for example, that the mode that we want to look at use is lines. We want to monitor the users JLong desktop in directory, and we want to look for files that start with or end with .txt. Okay, so we're going to hit OK, and then for the transformer, I'm going to say whenever a message gets sent, whenever a line is sent, I want to uppercase the line, and then I want to send that result to this destination, to the RabbitMQ destination. So let's go ahead and create that stream, and I'll call this files to reservations, right? I'm going to go ahead and deploy that stream, and it's going to go ahead and deploy the stream across as 3 different Java processes running on my local machine. But there are other Dataflow deployers that work on Cloud Foundry and Apache Mesos and Yarn and Kubernetes and whatever, right? So you can mix and match and so on. You can orchestrate across different runtimes. So runtime stream, it's deployed. So now if we go to our desktop here, desktop in, and I'm going to open up the atom.txt file. So we're going to say Josh, say Dave, Phil, Spencer, Marcin. There we go. So I'm going to save these names here. I'll say hi.txt, save that, and now if we go to our endpoint here, we can see there's Dave, Phil, Spencer, Marcin. So we're able to pull together complex solutions using messaging-based microservice primitives. Now, as in the last 10 minutes here, roughly, we're going to look at securing our services because we've done very little so far. I want to make sure we also have when we talk about production-worthy services, things should be secure. I've got an edge service that's responding to requests. You can see I'm calling this edge service unprotected. And in a microservices world, in a distributed systems world, it's very common to have lots of different kinds of clients that have different permissions and authorizations and scopes, right? So I don't want to just use usernames and passwords. If I just use usernames and passwords, I would have no idea about the device on which the request is being made. I would only understand who is making the request, not how they're making the request. And I need that extra information in a modern world because my HTML5 browser, for example, is intrinsically less secure than for example, your iPhone. An app deployed on the App Store that's signed and compiled and deployed into the firmware, for example, or into the operating system rather. So we want to be able to cordon these things off and treat them separately. Similarly, it's a bad idea for users to pass around usernames and passwords, right? If somebody steals the password, then you have to reset the password for all the other services that rely on that. So instead, you can use what is called an OAuth token. The way OAuth works is that it's a protocol for describing users. First of all, it doesn't actually describe users. It delegates to a identity provider of some sort, an authentication service, and then it provides the ability to manage tokens for the authenticated user. So instead of me going to Facebook and then, I'm sure you've seen this when you go to another website and it says, "Do you want to log in this website with Facebook?" You click the button, it redirects you to facebook.com. It says, "Do you approve of this website spamming your friends, your family, your loved ones mercilessly and endlessly until they hate you?" And you say, "Yeah, do it, absolutely." And then it redirects back to the actual third-party service. When it does that, it passes back a token to that third-party service. That third-party service never has your username and password. So if it does something malicious, you can go to facebook.com and revoke it. We can do the same thing. So what we're going to do is we're going to build an OAuth authorization server. First of all, this is a standard API. OAuth, we're going to use H2 and JPA, and they're going to use the config client and Eureka. Okay. And we're going to build a simple server that has 2 requirements. We need to teach our authorization server about the users, and that can be anything. You can integrate anything that Spring Security supports will work, but as we have very little time, we're just going to build a simple Spring Security-based identity provider that talks to a database based on JPA. Okay, so we're going to create a JPA entity here called an account that's going to be a sort of stand-in for our username and password system. And I'm going to have a username field like this and a password field and a Boolean called active and a ID, a private long ID that will signal as an ID by saying @ID and @generated value. Okay. Good. And now we need some getters. There's this. We need another constructor. We need more constructors for JPA and JPA alone. Okay. ToString. There's this, except for the password. Good. Now, we want to be able to read and write and manipulate that instance, so we're going to create a repository as usual. So we'll say account repository extends JPA repository, JPA repository, managing entities of type account, whose primary key is of type long. And we're going to have to teach Spring Security about this account world that we've just created. So we're going to create an implementation. We're going to adapt Spring Security's, we're going to adapt that JPA entity in that domain to the Spring Security world by creating what's called a user details service. So we're going to say account user details service implements user details service. And this is just a contract that is very straightforward, I think. It's when Spring Security is asked to authenticate a user by a username, it's going to call this method, and your job is to give it a implementation of that user details contract. And we're going to do so using our repository here, right? So let's go ahead and inject this here. And then we'll create a finder method here that'll return an account if it's available. Otherwise, just an optional that's empty, right? So find by username, string username. And there we go. Now, our job in this contract, in this endpoint, is to say account repository.find by username. If it's there, we're going to map it. So we'll do that in a second. We'll do that in a second. But if it's not there, we need to throw an exception, right? We're not supposed to return null. You're supposed to return a username not found exception, like that. Okay. So we're going to say new user, and that's a concrete implementation of the user details contract. And then we're going to say get username, account, get password. I'm going to say account.isActive. So it's going to ask you 4 questions, all of which can be answered in terms of is the account active. Then we need to describe the authorities for this user. I'm just going to hard code some users, some authorities like this. Role is a user, or the users are rather an admin and a regular user. So there's my very simple user detail service. I'm going to create some sample users, right? Sample account CLR. It's going to implement the command line runner. Same thing as before, and we're going to go ahead and create some accounts here. We're going to say private final account repository. Create a constructor and inject that result in here. And now I'm going to go ahead and create some users and passwords. So JLong and Spring, dsire, cloud, pweb, boot. These are usernames and passwords. I'm going to map them from x to x split, right? Like so. Oops. And then we're going to visit for each one, for each tuple. We're going to save a record in the database equals a new account. I'm going to say tuple of 0, tuple of 1, and true, because everybody's account is an admin and a user. You're lucky. Good stuff. Now, this is the basic Spring Security stuff. Now, the last thing we need to do is to integrate Spring Security OAuth. Now, Spring Security OAuth requires an authorization server, or just say OAuth config. I'm going to extend authorization server configurer adapter. And we need to implement 2 of these 3 these are empty no-op methods, but we have to implement 2 of them, not this one. And what we want to do in this authorization server config is tell Spring Security OAuth, first of all, about what we just described in Spring Security, right? We need to tell it how to delegate authentication. In this case, just do so by using the Spring Security stuff that we just set up, right? The username, user details, and user details service. So I'm going to tell it to delegate to that existing Spring Security infrastructure by creating an authentication manager. And I'll tell it to inject that here, and I'll say that endpoints.authentication manager equals this authentication manager. And then finally, I'll describe a client. In this case, I'll just use an in-memory database of clients, but a lot of websites have portals like developer.facebook.com or whatever. We can register arbitrary developer clients, client applications. So the scope in this case is going to be OpenID, and the authorized grant type will be password. This is the kind of flow I want to support. So there we go. The final thing we need to do in order for this to work is we need to create what's called a token info endpoint, right? So this is non-standard. Otherwise we would have it already, but it's not standard because, of course, it changes from one service to another. So if you're using Facebook, you'll get the Facebook friend graph information, right? If you're using GitHub, you'll get a GitHub information, for example, right? So this is different from one service to another. So we have to just have to create our own. In my configuration server, I've got it pointing. I'm going to point all the other microservices to this endpoint. So they're going to get a request that has a token in it, and they're going to wonder what to do with that token. And we're going to say, call this authorization server, pass the token to the authorization server, which is then going to translate it into a principal, which we then return to the client, to the other services, as a JSON structure, which it then can use to understand or ascertain whether this user should be allowed to proceed, right? So let's go ahead and start this up. And meanwhile, we'll go ahead and lock down our edge service, right? We're going to go lock down our edge service by going here and bringing in Spring Cloud Starter OAuth 2. And we have to do a fair amount of code to get this to work. Ready? @enable resource server. Okay, run. So what that's going to do is it's going to protect our resource, our endpoint, and it's going to use the configuration, the config server, to call the authorization server that we've already got. So here's this. Son of a gun. I'll take some water since... Where? What? Where? This? This one? Okay. I'm saying this dot. I'm dereferencing it. I'm dereferencing the current object. Okay, thank you though. So let's open up the browser plugin here to generate a token, right? We're going to generate a token. We should see that if I call the auth server using this REST endpoint, this call, I'm going to use the browser plugin if it loads ever. I'm going to use the browser plugin to send a valid request to the auth server running on port 9191 to get a token. Let's see if that works. There it is. Here's my access token. We can use that now to call that REST service, the edge service that we've just created. So we can say curl http localhost 9999 / reservations / names. Let's prove it doesn't work. Unauthorized, right? Now we can go here and we can say -h authorization : bearer paste. Good. There we are. So now I've protected my edge service using OAuth tokens. I've built a system that is robust enough to do the right thing and fail gracefully for both reads and writes. I've benefited from the elasticity of a cloud environment. I've done so in a fairly quick amount of time with great ASCII artwork to show for it as well. And, we've also looked at how to build messaging pipelines or stream-based pipelines using Spring Cloud Dataflow. Now, I hope you enjoyed some of what we looked at here today. I know that I went, not as fast as we should have, but maybe faster than you were expecting. So I want to invite you again to consult this URL here, this URL at the top there. That guide, that workshop is a 3-day lab that I do that has step-by-step exercises introducing everything that we just talked about and much more. So I hope you'll check that out. Also, Spring.io guides for the sort of topical 15-minute long introductions to all this kind of stuff. I'm going to be doing a book signing pretty soon. I think I'm in like 10 minutes downstairs in the book area. Also, the Spring Boff is up next. I hope you like this. I certainly liked it. I'm wearing a Spring t-shirt and Spring underwear. Of course, I liked it. But that said, you don't have to take my word for it, right? There are small mom and pop shops out there like Netflix, like Alibaba, like Baidu, like Ticketmaster, like Betfair that are using Spring Boot, Spring Cloud, and Cloud Foundry, or some permutations of those things in production. So I'll happily take questions if you have them. Thank you so much. Cheers.